Hello, and in today's iOS demo video, we're going to take a brief look at using the built-in local video. We're going to take a brief look at using the built-in local authentication API to authenticate with biometrics in your iOS app. Now, what do I mean by biometrics? Well, in the context of iOS devices, that means either TouchID on most devices or FaceID currently only on the iPhone X. So, you can use authentication for lots of different things, including I've even seen some banking applications using TouchID instead of using complex passwords. We can just the TouchID is stored directly on the device, so we can just authenticate with TouchID and make sure it's the same person. So that's what we're going to have to do today. Before we do, let's briefly review the processes that we need to undertake to authenticate with TouchID, because there's a very specific set of processes you have to follow. So we first have to check that we can authenticate with one of these types. Well, why might that not be the case? Well, if a user is on an older device that doesn't have a fingerprint sensor, or indeed if they're on the iPhone SE, which I don't believe has a fingerprint sensor, or there's some other sort of problem, they're not signed up for TouchID, or they're not enrolled in TouchID, that could be the case. Then we have to actually do the authentication, which actually we're not in control over this. The system puts up all the TouchID interface, and what we get back is at some point when TouchID is finished, we get the result back, and then we can use the result to do something in that application. Now, I'm going to show the simplest of all possible outcomes. We're just going to change some text based on the outcome, but you can extend this logic to see how you can use it to do more complex things inside of your application. So with that said, let's dive in and to take a look at some of this stuff. First, we need to authenticate the local authentication framework, which is where the TouchID and stuff is stored. So I'm going to say import local authentication. I'm just going to build my project again so we can use everything in the local authentication framework. So what is the basis of the local authentication framework? Well, it's a class called an LA context. We need to create another instance of LA context every time we want to interact with the security hardware. Why is that? Well, it's because the system is in control of that secure data, obviously. So we as a developer need a clear portal basically into that data, and we do that based on an LA context. So I'll just show you the app quickly. So we've got this button that's going to ask. We're going to click to check TouchID, and then based on the outcome, we're going to show something in that label. So when we click this button, we're going to create an LA context. So I'm going to say let context equal a new instance of LA context. I can then ask that context to do things. Well, what do we need to do? Well, first need to check that we can actually use TouchID, so, or the user has TouchID available. So to do that, I'm going to say context can evaluate policy, and this is going to return us a bool yes or no. So what do we put for this policy? Well, we don't actually create these policies. They're created for us. We can see what they are by typing a period. I happen to know the one we want is owner authentication with biometrics, but if you want to be able to use either biometrics or passcode, you can use the top one, but we're going to only allow biometrics. And then we're going to say it's going to ask us for this NS error pointer here. That's a bit odd. What this is going to do is essentially, if there is some problem even figuring out whether we can check or not, it's going to fill up whatever variable we pass it here with details about what the error was. Now, TouchID is a case where you really want to handle errors. There could be lots of cases where authentication doesn't work. The authentication hardware might be broken. They might not have the hardware. They might produce an incorrect fingerprint. And there's several layers of error handling you need to do. Because this is a demo, I'm not going to do that, but this is where you would do that. And actually, this doesn't even give you the option to pass in nothing. So how do we deal with this pointer on check? Well, instead of us just getting the error somewhere, it wants us to specify a variable that we can fill up with the error. So what we're going to do for that? Well, I'm just going to say var error is an optional NS error. Why is it optional? It doesn't say anything about NS optional here. Well, that's simply because there might not be an error, so we're going to say it's error. Now, if we built this, it wouldn't work because that's passing in the variable itself, not a pointer to the variable, and that's what we need, a pointer to the variable, just so that the compiler knows where it is in memory, so that if we need it, it can fill it up with information. So to signify a pointer, we use an ampersand, and you can see the compiler now works properly. So I forgot to put an if statement here. So if the policy can be evaluated, we need to go on to the next step of actually evaluating the policy. Now, here is where you really need to put an if statement to provide some alternative login for if they don't have TouchID, but we're not going to do that here. So next we need to evaluate the policy. So we're going to ask the context again. This time, can you please evaluate policy, and we're going to pass in the same policy that we asked it if it can evaluate. So in our case, the biometrics one. And now this is going to ask us to provide a reason that it's just going to put in the TouchID dialog for why we need to use it. So we're just going to say demo in this case. And it's now going to give us a closure with the containing the result and if there was an error or not. Now, why does it do this as a closure? Well, this is executed off the main thread and it can respond whenever it wants. Because the system is in control of this, our app isn't in control of it, so we just need to, whatever we put in this code will get executed whenever we get a response back, and then we can deal with it, but we can't just rely on when we're getting this response. So that's why we use this asynchronous, as it's called, closure. So we now have to name the stuff we got back so we can use them in the context of this code that we're about to write. So I'm going to call whether or not they got in successfully outcome, and then if there was an error, we're going to refer to that as error. So in this code here, we're going to check if outcome. So basically, this means if we got for all these earlier steps and they authenticated, we're going to do something. Or what do you want to do? Change the text on the label, or to refer to the label, we need to say self here. We usually wouldn't because we don't need self in Swift, but we're in a closure, so we do need self. So I'm just going to say self and edit that results text to just say yes. But what's the other case that we also need to take advantage of? Or what if they couldn't? Or what if they could authenticate, but when they put their fingerprint on, it was the wrong person? Well, then we need to provide an else statement. And I'm just going to change the text to no. I'm gonna run this and it's gonna work hopefully, but we're gonna get some odd behavior. So let's just see that. Now, if I click this button, you see that we've been this device has TouchID, so we've been asked to give a TouchID signal. The way you do that on the simulator is to say hardware TouchID, and then you can choose either a matching or non-matching touch. So let's start off with a matching. And then you notice here in Xcode, well, for one thing, if we write long enough, we'll get the answer yes, so it is working, but we get this strange purple warning out, and it's purple because this isn't actually from the compiler, it's from a third-party Xcode tool, but it's based on UI, this label text being set, not on the main thread. Now, threading is a very complex concept that, considering how this video is going on, I don't have time to go into in detail, but it basically means this part of the code, because it's not managed by our app essentially in this case, the this thread, basically, I don't use this thread so that the rest of our app doesn't get locked up while it's waiting to see if we can authenticate or not. This thread is locked, or it can't communicate with our UI objects, so that's actually why it was so slow to return. Not because TouchID is that slow, but because it was confused about what to do to this text property. Now, this is what's called, the fact that it was so long, it's what's called undefined behavior. Essentially, when you call things from the wrong thread, it might work as it did in our case, but the compiler just gets confused, and it's not predictable what it's going to do, so clearly that's not good behavior to have in a production app. So, how do we do this? Well, again, I'm not going to go into detail on this because it's not specifically about TouchID, it's about threading, but basically, when we get this information back before we do anything, we're going to say dispatch queue, put it on the main queue, and run a block of code asynchronously. So that essentially says, okay, do what you want, but then get us back to the main thread, which is where we can change our UI objects. And now if we rerun, we can press that button again, and notice we get our TouchID. In this case, I'll do a non-matching touch just so you can see what that's like. So we're expecting it to say no. You see, it says try again, but then if we cancel it without authenticating, we just get no straight away, and no warning here because these variables are executing back on the main thread. I'm going to do a video specifically on threading, but that was just how it came in that authentication. So a really good example of how simple Apple's APIs can be. This is a really small amount of code to do what is a really complicated thing. So thank you for watching this video. It was a lot longer than I wanted it to be, hoping to cut it down in editing, but yeah, thank you for watching, and I'll see you in the next video. Bye bye.